What will the universe look like after 10 trillion years? The answer may exceed your imagination. 3.7 billion years from now, the Milky Way and Andromeda galaxies will collide. After a long period of gravitational equilibrium, the two galaxies will merge into a larger galaxy. 5 billion years from now, hydrogen inside the Sun will be completely consumed. Its outer shell will expand under repulsive forces, becoming a red supergiant star. Earth and the Moon will enter inside the Sun by then, gradually decreasing their orbital altitude through friction, ultimately falling into the red giant's endless sea of fire. 10 billion years from now, the red giant Sun will dissipate into a planetary nebula, leaving behind a white dwarf in the central region. Next comes the time for the second law of thermodynamics to take effect. Over sufficiently long periods of time, we will discover that hydrogen available for star formation in the universe will become increasingly scarce, while heavy elements become more abundant. The ultimate result is that the universe will lack sufficient material to produce new stars. As a result, within just hundreds of billions to trillions of years, all stars in the universe will burn out. Neutron stars and white dwarfs will also cool down, unable to emit light or heat. Even black holes themselves will continuously lose mass due to Hawking radiation, ultimately evaporating in the universe and smoothing out the previously warped spacetime. In a universe where even black holes are gone, what remains is only cold and darkness approaching absolute zero. All material activity in the universe will be confined to the microscopic level, governed by quantum mechanics. If there are still humans in the universe at this time, then they would see a completely pitch-black universe, with no light sources in any direction. Time would also lose its macroscopic reference at this moment. This is the heat-death ending of the universe. However, some scientists believe that before heat death arrives, the universe will face another ending first, where all matter is torn apart by the force of cosmic expansion. Currently, the universe expands at 71 kilometers per second, per 3.26 million light-years. At this rate, once galaxies are more than 14.5 billion light-years from Earth, their recession velocity will exceed the speed of light, and they will be forever lost to us. Of the 2 trillion galaxies in the currently observable universe, 98% have already exceeded this distance. In the future, driven by dark energy, the universe's expansion rate will continue to accelerate. Given that dark energy currently comprises 70% of the universe, it will take only 22 billion years for the force of cosmic expansion to act upon every single atom. Before this happens, cosmic walls, cosmic voids, galaxy clusters, the Milky Way, and the solar system will all be torn apart by cosmic expansion. In the final moment, Earth and every atom composing Earth will also be torn apart. At that time, the entire universe will return to a fundamental particle state, perhaps continuing until the Planck scale, before stopping. Fortunately, dark energy has not yet been truly discovered, and remains merely an explanation for the universe's accelerating expansion. Future theories about cosmic evolution may present new possibilities, but one thing is certain: since the universe has a beginning, it must also have an end. However, for us, we have only lived for an instant of the universe, making it difficult to see many things clearly in this instant. Therefore, the universe remains enigmatic to us.